स्टूडेंट्स, अब हम लोग पढ़ेंगे फाइंड द nth डेरिवेटिव ऑफ e टू द पावर ax मल्टीप्लाइड बाई cos bx प्लस c। यानी आपको यहाँ पर nth डेरिवेटिव निकालना है e की पावर ax मल्टीप्लाइड बाई cos bx प्लस c। फॉर दिस फर्स्ट वी लेट y is equal to e to the power ax multiplied by cos bx plus c. Now first we differentiate this with respect to x, we get y1, that is y1 is equal to here d by dx of e to the power ax cos bx plus c. Here we use formula of differentiation for multiplication of product of two functions, that is one is exponential function and other is cosine function. So we write here first function e to the power ax d by dx of second function, that is cos bx plus c, plus second function cos bx plus c and d by dx of first function, that is e to the power ax. We know that differentiation of this cos bx plus c is sine of bx plus c, and here we know that differentiation of cos x is minus sin x, so we write sine minus sine bx plus c, and differentiation of this bx plus c is b because differentiation of x is 1 and c is the constant, so differentiation is 0. Similarly, when we differentiate e to the power ax, we get a e to the power ax cos bx plus c. Now taking common e to the power ax in both the terms, we get y1 is equal to e to the power ax minus b sin bx plus c plus a cos bx plus c. Now we put a is equal to r cos phi and b is equal to r sin phi. When we add square of a and b, we get a square plus b square is equal to r square. And when we divide r sin phi by r cos phi, this r is cancelled out, so sin phi upon cos phi is equal to tan phi, that is b upon a. Now when we put value of a and b, we get here minus r sin phi sin bx plus c plus r cos phi multiplied by cos bx plus c. Here we can see that this r is common in both the terms, so we take it outside the bracket, we write r multiplied by e to the power ax, and we write this first, so cos bx plus c multiplied by cos phi minus sin bx plus c multiplied by sin phi. Now we use here formula cos a cos b minus sin a sin b, and we know that cos a cos b minus sin a sin b, this is equal to cos a plus b. So we can write here this is r multiplied by e to the power ax multiplied by cos bx plus c plus phi. Now put value of r here, we get y1 is equal to under root a square plus b square multiplied by e to the power ax multiplied by cos bx plus c plus phi. Now we differentiate this y1 again with respect to x, we get y2, that is we write here differentiate again, differentiate with respect to x, we get here y2 that is under root a square plus b square and d by dx of e to the power ax multiplied by cos bx plus c plus phi. Here we can see that under root a square plus b square is constant, so we write under root a square plus b square outside the bracket, and here e to the power ax and cos bx plus c plus phi are in the multiplication. This is multiplication of two functions, one is exponential function, other is cosine function. So we use formula for differentiation of multiplication of two functions, that is, here we write y2 is equal to under root a square plus b square. First we write first function d by dx of second function, that is sin bx plus c plus phi, plus second function, that means cos bx plus c plus phi, and d by dx of first function, that is e to the power ax. Now we differentiate, we get here, we know that this differentiation of sin bx plus c plus phi, this is cos bx plus c plus phi, and also we know that differentiation of bx plus c plus phi, here c and phi both are constant, so the differentiation of c and phi is 0 and the differentiation of bx is b, because the differentiation of x is 1. Similarly, differentiation of e to the power ax can be written as a multiplied by e to the power ax and cos bx plus c plus phi. Here we can see that e to the power ax is common in both the terms, so we take e to the power ax is outside the bracket, so we can write e to the power ax multiplied by a square plus b square, and in the bracket we can write here b cos bx plus c plus phi, plus here we can see that this uh, one is e to the power ax cos bx plus I, here this is cos bx plus c plus phi, and here when we differentiate this cos bx plus c plus phi, we write here minus sin bx plus c plus phi, so this is minus sin bx plus c plus phi, and here a cos bx plus c plus phi. Now we put value of a and b here. A is equal to a cos phi sorry, and b is equal to r sin phi. So we write here e to the power ax multiplied by under root a square plus b square, and in place of b is r sin phi sin bx plus c plus phi. In place of a we write here r cos phi multiplied by cos bx plus c plus phi. Now we can see that this small r is in both the terms, so we take common outside the bracket. We write here r multiplied by e to the power ax multiplied by a square plus b square, and we write first cos bx plus c plus phi multiplied by cos phi minus sin bx plus c plus phi multiplied by sin phi. Here we use formula cos A cos B minus sin A sin B, that is equal to cos A plus B. So we can write here r e to the power ax, and this one is cos bx plus c plus phi, and we know that this under root a square plus b square, from here we can write this is small r. So this r and this r multiply, we get r square e to the power ax cos bx plus c plus 2 phi. When we substitute value of r square here, we write y2 is equal to a square plus b square e to the power ax cos bx plus c plus 2 phi. Now this power of a square plus b square can be written as 2 by 2, because 2 by 2 is 1. So we know that when differentiate e to the power ax multiplied by cos bx plus c one time, we get here power of a square plus b square is equal to 1 by 2. When differentiate 2 times, we get power of a square plus b square is 2 by 2. Similarly, when we differentiate n times, we get power of a square plus b square is n by 2. And we know that on differentiation one time we get here e to the power ax. On multiplication, when we get differentiation two times, so here e to the power ax. Similarly, when we differentiate n times, here we get e to the power ax. Now we can see that when we differentiate one time, here we get 1 5. When we differentiate two times, here we get 2 5. So when we differentiate n times, we get here n 5. So this formula can also be written as dn e to the power ax cos bx plus c is equal to a square plus b square whole power n by 2 multiplied by e to the power ax multiplied by bx plus c plus n 5, where phi is equal to tan inverse b by a. तो स्टूडेंट्स आप देख सकते हैं यहाँ पर हमको एन डेरिवेटिव फाइंड करना है e की पावर ax मल्टीप्लाइड बाई cos bx प्लस c को. So first we suppose that this is equal to y is equal to e to the power ax multiplied by cos bx plus c. अब इसको हम वन टाइम डिफरेंशिएट करते हैं x के एस्पेक्ट में, तो इससे हमको y1 मिल जाएगा. y को जब वन टाइम डिफरेंशिएट करेंगे x के एस्पेक्ट में तो y1 मिलेगा. और राइट हैंड साइड में टू फंक्शंस हैं, वन इज एक्सपोनेंशियल फंक्शन, अदर इज कोसाइन फंक्शन. तो इन दोनों का प्रोडक्ट का डिफरेंशिएशन करने के लिए d by dx ऑफ e to the power ax into cos bx plus c. अब इसमें हम यूज करेंगे फार्मूला फॉर डिफरेंशिएशन ऑफ प्रोडक्ट ऑफ टू फंक्शंस. तो आप देख सकते हैं फर्स्ट फंक्शन e की पावर ax है, सेकंड फंक्शन cos bx plus c है. तो फर्स्ट फंक्शन e की पावर ax d by dx ऑफ सेकंड फंक्शन यानी cos bx plus c, सेकंड फंक्शन cos bx plus c, फर्स्ट का d by dx हो गया e की पावर ax. अब आप देख सकते हैं यहाँ पर we can see that differentiation of cos bx plus c. So we know that differentiation of cos x is minus sin x. So we here write minus sin bx plus c. And when we differentiate this bx plus c, so differentiation of c is 0 and differentiation of x is 1 and b is here. Similarly, when we know that differentiate e की power ax, we get a e to the power ax and this cos bx plus c. देखिए आप यहाँ पर जब e की पावर x का डिफरेंशिएशन करेंगे तो ये a की पावर x आएगा, और cos x का डिफरेंशिएशन माइनस sin x होता है तो ये माइनस sin bx plus c होगा. फिर bx plus c का डिफरेंशिएशन करेंगे तो b कांस्टेंट होगा, x का डिफरेंशिएशन 1 होगा, c कांस्टेंट है, x का डिफरेंशिएशन 0 होगा, इसलिए b मल्टीप्लिकेशन में आएगा. Now here we can see that e to power ax is in both the terms, so we take common outside the bracket e to power ax and we write here minus b sin bx plus c plus a cos bx plus c. आप देख सकते हैं इन बोथ टर्म में e to the power ax है, इसको हमने कॉमन लिया, आउटसाइड द ब्रैकेट लिखा और माइनस b sin bx plus c plus a cos bx plus c. अब यहाँ पर हम पुट कर रहे हैं a इक्वल टू आर cos phi, b इक्वल टू आर sin phi. जब इनको आप स्क्वायर करके ऐड करेंगे तो a स्क्वायर प्लस b स्क्वायर इक्वल टू आर स्क्वायर cos स्क्वायर phi प्लस आर स्क्वायर sin स्क्वायर phi होगा. आर स्क्वायर कॉमन लेंगे, cos स्क्वायर phi प्लस sin स्क्वायर phi 1 होगा, यानी a स्क्वायर प्लस b स्क्वायर आर स्क्वायर के इक्वल होगा. और r sin phi को r cos phi से डिवाइड करेंगे तो r r कैंसिल होगा, sin phi अपॉन cos phi tan phi होगा, tan phi इक्वल टू b अपॉन a होगा. तो आप देख सकते हैं when we here we put a is equal to r cos phi and b is equal to r sin phi, when we add square of a and b, we get a square plus b square, that is r square cos square phi plus r square sin square phi. We take common r square, that is cos square phi plus sin square phi, and we know that cos square phi plus sin square phi is 1. So in value of a square plus b square equal to r square. When we divide r sin phi by r cos phi, this r is cancelled out. Sin phi upon cos phi tan phi is equal to b upon a. So value of phi is equal to tan inverse b upon a. Now we put here value of b and a, that is r sin phi. Here we put value of a, that is r cos phi. आप यहाँ पर देख सकते हैं b और a की वैल्यू रखी गई है, a के प्लेस पे r cos phi और b के प्लेस पे r sin phi. Here we can say that this r is common in both the terms, so we write this outside the bracket and this can be written as cos bx plus c multiplied by cos phi माइनस साइन bx plus c multiplied by sin phi। आप देख सकते हैं यहाँ पर r कॉमन मिल रहा है, इसको कॉमन ले लिया और ये पॉजिटिव टर्म है, इसको पहले लिखा है cos bx plus c multiplied by cos phi, then minus sin bx plus c multiplied by sin phi। Here we use formula cos a cos b minus sin a sin b, that is cos a plus b, so we can write here cos bx plus c plus phi and put value of r is here, that is r is equal to under root a square plus b square, so we write r is equal to under root a square plus b square, so we get y1 is equal to root of a square plus b square multiplied by e to the power ax cos bx plus c plus phi। यहाँ पर हम r की वैल्यू रख रहे हैं, यहाँ से निकाल के अंडर रूट a स्क्वायर प्लस b स्क्वायर है। अब डिफरेंशिएट विद रिस्पेक्ट टू x अगेन, इसको हम इन डिफरेंशिएट कर रहे हैं with respect to x, so we get y2 and here under root a square plus b square is constant, so this will be right outside the differential operator and we use formula of differentiation of product of two functions, that is e to the power ax and cos bx plus c plus phi। So first we write e to the power ax, then d by dx of cos bx plus c plus phi plus second function cos bx plus c plus phi and d by dx of first function e to the power ax। नाउ आप देख सकते हैं cos bx plus c plus phi का डिफरेंशिएशन होता है माइनस sin bx plus c plus phi, और जब bx plus c plus phi को डिफरेंशिएशन करेंगे तो c और phi कांस्टेंट है, इनका डिफरेंशिएशन 0 होगा और bx का डिफरेंशिएशन 1 होगा। इसी तरीके से e की पावर ax का डिफरेंशिएशन a e की पावर ax होगा और ये cos bx plus c plus phi। We know that differentiation of cos bx plus c plus phi is minus sin bx plus c plus phi। When we differentiate c and phi, these are constant, so differentiation of c and phi is 0, and when we differentiate bx, we get b because differentiation of x is 1। Here differentiation of e to the power ax is a e to the power ax। Now this e to the power ax in both the terms, so we take common e to the power ax and we write this outside the bracket, so here minus b sin bx plus c plus phi plus a cos bx plus c plus phi। आप देख सकते हैं e की पावर ax इसमें कॉमन हो गया और बाकी ये बच रहा है। अब now we put value of b and a again, here r sin phi and in place of a is r cos phi, so we can see that r in both terms, so we take common and write outside the bracket, so we write minus this first cos bx plus c plus phi cos phi minus sin bx plus c plus phi multiplied by sin phi, and also we know that cos a cos b minus sin a sin b, this is equal to cos a plus b, that is